Welcome back to another Sunrise 2.x tutorial video. Today's topic will be on the basic programming and basic use of the RAPI, or Robot Application Programming Interface. So to get started, go ahead and right click on the source folder, go to New Package. Here we can give a name for our Java package. Mine will be called com.tutorial.examples. Here I will be placing all of my tutorial classes for the upcoming example videos. Here we can go to New and Sunrise Application. Here we can choose from two different templates. The Robotics API application is kind of like your main instance or your main application where you'll be doing most of your robot programming. The background task is a parallel instance where you can monitor peripheral devices or like the robot state. So for now, let's focus on the Robotics API application. Go ahead and hit Next. Here we can name our application. So I'm going to name mine RAPI Basics Example. So RAPI stands for Robotics Application Programming Interface. So with the start of a new template, you can see we have our class name here, and it extends this Robotics API application. By extending this Robotics API application, we have to override the initialize method and the run method. The run method would be kind of like your main method in a Java class. So the first thing that I do typically in a template is I go ahead and I just rename this very long robot name, and I create it simpler, just called robot. So let's just get started with a very basic example. Let's just print hello world to the SmartPad. So let's start by typing in get. If you hit Control Space, you can arrow key through different objects and methods and interfaces. If you hover over one of them, you can see the Java docs on the right hand side, and if you click on the Java doc, you can actually open the entire class Java doc inside of this browser window. So here we can Control Space, get logger.info. In info, you can provide a string as a parameter. So here we can type in hello world, just like that. And if we were to hit the save button up here and say synchronize project, hello world would be printed straight onto the SmartPad. So now let's move on to a robot motion example. So as a really brief overview, what we're going to do is we're going to basically grab this robot object, we're going to grab this flange frame here, and then we're going to physically move this flange frame to the home position. So let's just grab this robot object, get the flange frame, and go ahead and move. And we're just going to use a PTP home method, which is a dedicated method to moving the robot home. And it's as easy as that. So this PTP home method will always go to the 0, 0, 0 joint position of the robot. So if we wanted to set this new position, if we wanted to set this home position to something different, we could access this robot object and say set home position, and then we can actually give it a new joint position. So here we go, joint position dot of degree, and then we can provide 7 different degrees for, or a different degree for each joint, which would be 7 different values. So here we have all zeros except for A4, which is 90, and A6, which is -90. This will be like an elbow up configuration. So now if we were to run this and synchronize the project, we can see that it will indeed print hello world, and then it will move this robot to this new home position, which is this elbow up configuration. So now that we've moved the robot to its home position, let's try moving the robot linearly to some target frame. Let's say we hypothetically know the transformation from the world frame to this target frame. Well, we can actually go to our scene graph here. We can go to world, and then right click on root and say new frame as child. Here we can give it some name. I'm going to call mine tutorial frame. I'll be using this frame in future videos as well, so be sure to save it. Here we're going to give it some transformation from world. So you can follow along. So -200 in X, 250 in Y, 700 in Z, 150 degrees around A, -20 around B, and around C, negative 150 degrees. Now, this X, Y, Z, and A, B, and C that we just provided are positioned relative to the parent frame. And the parent frame of our tutorial frame is our root frame. So our world frame is at 0, 0, 0, 0, 0, and it always has Z pointing straight up. And from that frame, we are rotating around A, and then B, and then C, and then our X, translating in X, Y, and Z. So if we save this tutorial frame now, how do we access it inside of our program? Well, if we look at our scene graph, we need to access the scene graph. Then we need to access our world object so we can access our tutorial frame. So we're going to do just that. So we're going to say scene graph dot get world dot find frame. And then here we can say tutorial frame. So we basically accessed our scene graph, then we accessed our world object, and then we found our tutorial frame. Now we can actually make this even simpler by just grabbing the world object. So if we @inject and we create a new world. So now we've just injected our world. We can go ahead and import this com.kuka.geometry package. So now we have access directly to the world object. So we can shorten our line of code by just saying, let's access this world object, and we're just going to find the frame directly, since our frame is directly underneath the world object. One cool trick that you can do is we can highlight this line of code, right click, refactor, extract local variable, and we can give it a name. So I'm going to call mine target frame, since this is where we would want to move to. And you can see now we are saving our tutorial frame inside of our target frame. And our target frame is where we want the robot to move linearly to. So how do we get it to move to our target frame? Well, we can grab our robot object. We can say get flange, since we want our flange to move. And we're going to tell it to move linearly to our target frame. Go ahead and import the package that holds our lin class, and that's all. So now if we were to save and synchronize project, we will be printing hello world to the SmartPad. We will be getting our robot object, getting the flange, and telling it to move to our home position, which we set here. And then finally, we'll be grabbing our tutorial frame from the scene graph and telling our robot to move linearly to this target frame. Let's briefly run through one more example. So let's say we want to move linearly back to our home position. Well, this is an issue because our home position currently is in the form of a joint position, where our linear can only accept a Cartesian frame. So to get a Cartesian frame from our joint position, let's just go ahead and create a new pose, and we'll call this home pose. Grab the robot object and say get forward kinematics. Here we can pass in a joint position dot of degree, and we'll just pass in the joint home values. Now, if you're unfamiliar with the forward kinematics, what that is briefly is we're basically grabbing this robot object and we're going to build a transformation from the root of the robot to the flange of the robot. So when we do a forward kinematics, we can turn a joint position into a Cartesian pose, and that goes from the root of the robot to the flange of the robot. Go ahead and import this pose. So now that we have our pose, we need to create a frame because we can only move in Cartesian frames. So we'll create a frame, call this our home frame, and we'll construct a new frame called new local frame. And our local frame, we have a couple different options, but we're going to choose the one that says frame parent and I transformation trafo from parent. Now, our parent, really easy because our parent starts at the root. When we do our forward kinematics, it goes from the root to the flange. So our parent is just the robot root. So we can say robot.getRootFrame. Now our transformation, remember when we did our forward kinematics, we're getting our transformation from our root to our flange. So our transformation is just our home pose dot get transformation. So by providing the start of our transformation, or the root frame of the robot, and then providing this transformation to go from the parent or root to the flange, we now have our home frame. So now with our home frame, so our joint position is now in our Cartesian frame, we can say robot.getFlange. We want to move this flange linearly to our home frame. We could also say we want to set some velocity parameter on this. So we can say set Cartesian velocity, and let's just say 300 millimeters per second. So now if we went ahead and saved our project and we synchronized it, when we run our RAPI basic example program, we would see hello world printed to the SmartPad. We would see our robot move to the new home position, which we set up in our initialize. We would then be grabbing our tutorial frame from the scene graph and moving the robot flange to that tutorial frame, which we've called target frame now. Then finally, once it's moved to the target frame, we would be grabbing our home position in the form of a Cartesian frame and moving the robot flange to that home frame at some set Cartesian velocity. And with that final example, that will now conclude our tutorial on the robot application programming interface and basic programming inside of Sunrise Workbench.